Hello and welcome. Today we're going to go through an update on the Qualcomm status upstream. I'm Bjorn Andersson. I'm a maintainer of the Qualcomm SoC code upstream and device trees pieces. Been contributing to the upstream Qualcomm support for almost 8 years now. We're gonna go through what has happened since we met last in San Diego 1.5 years ago, I think, and a little bit of where we're going or what's ongoing right now. But first, let's define who we are. So if we look at the activity on the mailing list and in the kernel and so on. The biggest contributors are people coming from Linaro, Qualcomm, and Google. But interestingly enough, the last maybe 2 years, we have seen a lot of community activities, both from individual contributors or contractors for various other projects, or from post-market OS. And from the SO mainline team. So it's been a broad range of contributions. And there's also the general kernel community has contributed quite a bit of bug fixes and things like that. So what have we done? So since we met last time, there's been maybe less progress than before, but there's been good progress on the 8974, which now is a very old platform, although it did land on Mars. Unfortunately, not our version of the software. We saw the interconnect provider appear. I think we had OCMM patches on in flight last time we met. Those have now landed. We got some free CPU freq updates. And we got a lot of DT updates. There was quite a bit of code that was in place that has been tied up in DT in the DT files. So I think the major piece left to make 8974 something fun is the display and GPU side of things, which depends on SMU support, and that would be the Qualcomm IMMU driver, which has been resisting our attempts to get it to work. And there's been a couple of efforts that I'm aware of. Last time I saw it, it was functional but not stable. So I think the status is that we can have GPU support for a couple of minutes, and then the SMMU gives up or locks up. We have a whole bunch of different, primarily phones supported on this platform. At least all activity is there, and in particular, the community efforts has been quite focused on the Hammerhead, the Nexus 5 device, which has quite good support or has quite broad support in the DTS. Going forward, the 8916 platform, we in the landing team used to spend a lot of our focus on this, but it's been ramping down, both because it's fairly, feature-wise, it's fairly mature, but we have newer interesting platforms that we poked at. Since San Diego, we had the work from Ulf on the cluster idle side. That got landed and integrated on the device tree side. The interconnect framework and the interconnect provider for this platform was landed and enabled. There's been a community effort on getting the RPM PD, the corner support in place, and there was a nice set of cleanups, in particular in the remote proc drivers, to get some of the hacks I integrated originally out of those. So that looks pretty nice now. faster RPC was enabled. We got the CCI driver finally, which is the camera-specific I2C adapter or I2C bus. So that's finally in place. I think we're just some DT away from being able to support the various camera mezzanines. And there is overlays available for that. There was a fair amount of churn or cleanup on the DT side. Yeah. And I think when we met last time, we primarily had the 410 Dragon board supported, but there's been a lot of community effort on getting more device tree pieces upstream, new devices, and a lot of this seems to be driven from the post-market OS, which has seems to have a quite nice 8916 community. So it's always fun to see new boards and see when patches comes out of that. And last time I looked around, I saw that there were some efforts there. For example, someone has I'm not sure if they're ported or rewritten. Well, it looks rather different from the downstream driver. So there is a BAM DMUX driver. So maybe there's some there is some data connectivity on the horizons. I'm hoping to see those patches make their way upstream sooner rather than later. On 8996, last time we met, it was not possible to boot 8996 without KPTI equals no. And I believe from that, there was a discussion that ended up pointing out that maybe a year earlier, the CPU errata handling in ARM64 had been reworked, and there was and the CPU erratas that we needed for 8996 was not enabled. So with that in place, it was finally possible to boot the 8996 devices reliably again. There was a little bit of work left on getting GPU and display sorted out, just working out of the box. So that was taken care of. The CCI driver, the camera interface landed as well. And there's been some cleanups on the camera side there. So we have, I think we are at the point where it's DT overlays away from having support for the camera mezzanines there as well. There was an 8996 specific UFS PHY for the generic QMP block. That was deprecated and replaced with a generic one. And we modernized the DTS files and cleaned those up. And I think it was since we met that I merged the IFC 6640 support. But so far we only have those two boards. I know that there is community efforts on adding a couple of phones on this platform, so I'm looking forward to see the patches for that. On 8998, there was quite a large effort from Jeff on trying to get Jeff Hugo trying to get the 3 Qualcomm laptops on this platform operational, and from this we saw a couple of SMU fixes. There was GPU clock controls. There was, I think, the entire multimedia clock controller was added as well. And we did some work on remote procs to get Wi-Fi working, and there was Bluetooth in order as well. I think there's still a few pieces left on the display side to get that actually fully operational. In particular, or we're at least missing the DT patches. So there is still some work needed there. So both on 8996 and 8998, the biggest missing piece is for it to be functional is CPR and CPU FREC support. But maybe 2 months ago, Angelo posted a big patch set adding support for this on 8998 and I think 660, and I think it will also apply back to 8996. But that patch set needs review, and it's been sitting on my to-do list to do that. But I hope someone can get to review that someday, because getting that in order would complete, or in particular for 8996, would complete that platform upstream to make it really usable. And same thing here. We have the MTP, the development board. We have the 2 laptops supported, but I've seen that there is quite a few of phones being worked on the side or in the community. So hopefully we will see those show up someday as well. Again, when we met last time, we had a bunch of things in flight for the QCS404 platform. There was interconnect provider. We had the CPR driver was starting to take good shape, and that was the first platform that has support for the first CPR driver, which is deals with dynamic voltage scaling, or figuring out what voltage we should have a particular performance level. So that was landed and integrated with CPU FREC. We have seen some patches based on that, or some work based on that to backport that or add support for 8916 based on this. But so far, I think this is the only one that has landed. And the 8998 work is also based on this to some degree. We had USB, Watchdog, some remote proc drivers that was also in flight. These all landed. There was a couple of remote proc debug features, primarily related to post-mortem debugging. They all made it into to mainline. The next platform is the 660 platform. We have, as you can see, we have a little bit of everything. There's pretty broad support for this. The one piece that currently problematic is the SMMU. It's a quirky, or the hypervisor provides a quirky interface where it seems like the stream mapping registers are maybe read-only, or at least certain types of writes to them causes it to trigger security violations. There is some outstanding patches on the mailing list, and I think those needs to be reworked based on some other SMU work that was done. But hopefully you can get that in order. And there is a lot of effort here, because the really interesting thing with 660 is that it's completely a community effort, primarily driven by the SO mainline guys. So it's really fun to see when there's progress here. So there is SMU there, and we have the CPR, the CPU FREC patches here as well, and and there is quite a lot of device tree patches, both to add more functionality to these existing boards, phones, and to add some new pieces as well. So it's an interesting platform, or it's interesting outcome of the community project on this. So last time we met on 845, we had things working okay. A lot of things in flight. Primarily, we had 2 workaround patches that had to be applied, or 2 things that we had to apply on the SMU. There was an errata thing that without that we would get maybe thousands of performance on the various buses than we should. So we had that merged, and we got things like UFS and was picking up speed. The other thing was when we boot the Qualcomm platform, we typically have the bootloader put up some sort of boot splash or an EFI frame buffer, and it does this with by setting up this, or when it does this, it sets up the stream mapping for through the SMU, and as the ARM SMU driver probes, it would reset the hardware block and clear the stream mapping, and the display would no longer be able to reach the memory for displaying the frame buffer or to reaching the frame buffer, and the devices would crash. So after a lot of back and forth on that, we finally came to a conclusion, and we were able to boot 845 and all the newer platforms with some sort of boot splash, or with display initialized. There was also work ongoing for per process page tables for the GPU. That was later agreed upon, and those patches are also on the SMU side. They are also in place. We had there was work ongoing for supporting wake-up capable GPIOs. So when we put the SoC in deep sleep, the GPIO block, the TLMM, is no longer powered. So we need some other mechanism to get out of that mode, and there is a separate hardware block in the always on domain that deals with this. But the interaction between the TLMM block and this other component, the PDC, that was a long-going discussion about how to model that, and that all landed since we met. PCIe was in flight, that landed, so that works fine, which means, And then we had all the audio code. There was SoundWire support, and there was the platform sound drivers, and there was a couple of audio codecs that was the hardware codecs that was needed to be supported, and that's all in place. We had work ongoing on IPA, the network or the hardware block that shuffles data packets back and forth to the modem. That got accepted. We have the crypto driver that was written for some earlier platform has been refreshed and now has support for 845, and the camera subsystem was updated to support this platform as well, and that was merged very recently. This brings us everything but the ISP, so you can get raw data from a camera sensor, and presumably we can get YUV data from if we have a YUV sensor attached. We got a WLED driver for devices that has a backlight. On the Dragon board or the RB3 side, we have a DSI HDMI bridge that the driver for that was updated and cleaned up. Pretty much rewritten from the vendor driver, but they cleaned up to the point where it was accepted upstream. We have a PCI to USB hub sitting there to provide additional USB ports and that requires firmware loading to be operational. That was also landed. We have CPU FREC based DDR scaling. So as the CPU scale frequency, we will also scale the DDR frequency. And then for on the phone side, we I2C sits or is configured in a way where we need to use the specific DMA controller or DMA engine in the low speed controller. So that ended up being the GPI driver that was upstreamed earlier this year, maybe end of last year. And that enables, or that will enable some touch screens, for example, is quite typically sitting behind one of these. And then we have had the protection domain restart feature, which for some of the firmware running on the DSPs on these on the modern devices have multiple OS instances running, or multiple domains running, and we needed a PDR framework to know when these are booted and if they restart and so on, so we don't start talking to the firmware before it's ready, for example. We have the MTP and we have the DB845C, or the RB3, but we also have a couple of phones. We have the OnePlus 6T and the Poco phone supported upstream, various degree of functionality, but there's nice progress going on there. And we also have the Lenovo Yoga C630, which is a Windows on Snapdragon laptop based on this platform. Yes, we had a completely new platform showing up, the SC7180, or 7C as it's known outside or in the public. We have all the usual components, CPUs, timers, all the clocks, interconnects. There was a couple of interesting things that was landed here, in particular the interconnect. We started to see some interconnect integration with clients, and also we have the problem that the feature that bus bandwidth, so bus votes, can be tied to whether or not the CPU cluster is running or not. So we have this for clocks, interconnects, and regulators. So for clocks, it's been implemented since before, during the SC78, or for the 7880, 7180. This was implemented for interconnects and tied in. And we saw adoption in many drivers for this platform, which has trickled down to other platforms. There's USB, SDHI, the UART, I2C, the usual devices. Display, GPU, DSI is all supported, and FreeDRAINer support is there. There's audio support, and there's modem, and IPA is fully functional, providing data connectivity to the main Linux system. I believe that there is a few pending patches to enable some of the features, but otherwise this is pretty feature complete, or most features are present and enabled upstream. We had started work on 8150, and since then we got interconnect providers. We had the work done on 845 for SMMU. There was a couple of more tweaks that was needed, but then the 8150 finally could reuse that. We got UFS and USB PHY updates and got that enabled. And I think it was on this platform that some of the Type-C work was happening as well. We got the remote proc drivers, which together with SMU gave us Wi-Fi. The GPU is in the GPU support is in place. There's thermal profiles and core site in place, and there was some patches from the community to integrate the cluster idle. So we had only implemented that on in 9.16, but received patches from a community member adding it here, and yeah, that's definitely nice to see it being added to a newer platform. I think we have all the pieces for display, but it's not integrated in the device tree. So we at least need the device tree pieces to get that updated. And we continue to support MTP, but we also got patches for the 855 hardware development kit, which is a dev board from Qualcomm, which is publicly available. So a new platform, the 8180X, which is known as the HCX platform. We have the base pieces in place, the CPUs, timers, UART is in place. We have the basic clocks, regulators, RPM, HPD is in place. TLM provides GPIOs. CPU FREC cluster idling seems to be working, although we're not cluster idling, or we're not. I don't think we're saving any real power as it's configured right now. But the plumbing is there at least. Got the UFS PHY and USB PHY in place, and that works. The interesting, or the odd thing on this platform when it comes to USB is that it has its usual two USB-C controllers with their own QMP PHYs, but then it also has a third DWC3 instance, which is connected to two pairs of PHYs. So it seems to be a multi-host setup, and that's used for internal USB functionality on the laptops. But it's providing two sets of additional USB ports. We have remote procs and Wi-Fi in place. There's patches in flight for display clock controller, GPU clock controller. Rob Clark wrote an embryo of the DPU, or wrote some patches for the DPU driver. I made some additional work on that, so we think that the display is at least somewhat in order, but we don't have any of the interfaces to get anything out of it yet. Same thing with Adreno. We've done the initial plumbing, but we'll see once we get some pixels out of this, we will see where we are. There's presumably some Adreno work that's needed on this. There's also patches in flight for interconnect providers that needs to be a little bit cleaned up and then posted. And we have two boards supported here on this platform. There's the Primus development board, and there is the Lenovo Flex 5G laptop. The 5G laptop, it has currently EFI FB and keyboard touchpad, so it's possible to run X in unaccelerated mode. And there is also a Debian installer available from the ARch64 laptops project. So another new platform that has arrived is the 8250. There's been a lot of work on this as well. Most features are supported upstream. There was a new interrupt router, the IPCC in this one, rather than or related to signaling between remote procs and Linux, and a few other features. So that arrived here, and I think it's used in the following platforms as well. we have most things, or a lot of the things on this platform is in place. One thing that's pending upstream is the Wi-Fi chip needs a power sequence in order to be powered on, and it's the Wi-Fi sits on PCI, and the Bluetooth in the same chip sits in UART. So that there's patches proposed by Dimitri for how to handle this, but we haven't agreed on anything yet on how to handle that. There's MTP, there's the 8250 HDK, the public hardware development kit, and there is the RB5 board that Deb spoke about this morning. And on RB5 we have seen the HDMI bridge driver was upstreamed or was accepted upstream, and there's support for Ethernet and CAN bus on that as well, in addition to all the usual, or all the other platforms features. Recently announced was the Snapdragon 888 or 8350, and we got support for CPUs, timers, UART upstream, the global clock controller, regulators, corners, GPIOs are there, CPU FREC is there. We have initial support, or we have the base support for all 6 PMICs you normally find on this platform. There's USB, there is storage, even though I forgot to write that. And we have the remote proxy in place. There's the interconnect providers are in place, and I saw earlier today that we have patches for thermal profiles on the mailing list. So we have the MTP, and we have the new hardware development kit that support for those in Linux Next. And there we have storage, USB, and Ethernet is working currently. Yet another platform is the SDX55, which is a modem platform. So it's a single 32-bit ARM with a modem subsystem and some useful peripherals. So upstream we have support for the CPU with timers, UART, the clocks are there. We have interconnect provider, we have USB, SDHI. We have there was a bit of work to get the existing NAND driver to support this new configuration, and also some work on getting partition table, which Qualcomm typically pass to the bootloader or to the kernel through SMEM. So there is a SMEM partition parser that came out of this as well, and there's ongoing work on, there's patches available for the remote proc for the modem, and there's ongoing work on supporting IPA on this platform. Another large, I should say here, it currently supports the MTP, but there is a publicly available development board that will soon be supported as well. Another very large chunk of work was done in MHI, which is a Qualcomm mechanism for dealing with multifunction PCI devices. So similar to how we have USB devices providing various functionality, MHI provides that for PCI devices as well. Out of this came the ATH11K PCI support. There was the integration with the Q router for passing around QMI messages. there's been a lot of work going on to support the network interface exposed by these devices. So there is a MHI network driver, and recently there was support added for MBIM over this. So the MHI network drivers either used with raw IP packets, or you can do RMNet over it, or MBIM, depending on what kind of depending on if you need muxing or MBIM, or you want to use MBIM. There's been patches posted for the integration of or for the setup of the data calls in libqmi, and some work there and in both there and in Modem Manager to support this out of the box. But that's pending agreement on how the control messages should flow between libqmi and the modem control interface. The protocol is very similar to what we have seen in USB modems previously, but the proposed driver for exposing an interface to do just that was objected to, and there's an ongoing discussion there. And one thing that came out of the Wi-Fi work on AF11K was that there was an opposition to relying on the QRouter name server, which keeps track of where QMI services are in the system that used to live in user space, and it was migrated into kernel space. So that's all. Or that's not all. That's a large part of what happened since we met last time. But there's been this and a lot of bug fixes, improvements, and I probably missed a couple of features as well. So there's been a lot of work going on all over the place on all the different platforms. So where are we going now? On the connectivity side, as I said, there is patches available for external modems. There's also a set of patches for libqmi and Modem Manager related to internal modems or integrated modems. So one such example is the 845 laptop, where we have the IPA support in the kernel to shuffle data packets, and with the patches available in libqmi and what's presented for Modem Manager, or what's on review in those two projects, it's and a little bit more details. It's possible to get the data call going. On the IPA side, so we have 845 and the 7C support. There's a couple more platforms, work on it going on a couple more platforms, and there's a community effort in supporting 8998. So patch for that showed up on the mailing list maybe a month ago. There's performance, there's power improvements, there's performance improvements work being done on the IPA driver, and some work on checksum offloading, for example, but more features in the IPA on the IPA side. Another thing that we've started to look into is what in the Qualcomm kernel is known as the ESOC framework, which probably stands for external SoC. And that's when we have something like the SDX55 platform integrated onto the same PCB as, for example, an 8250 mobile platform. They typically they communicate over PCIe, but some of the power management between these are shared, and for that we need some sort of power sequence mechanism to express how we turn on the modem and how we and then there's a mechanism for the modem to when, for example, the firmware is crashing, we will know through GPIO pins that this happens, and there will need to be like a power sequence to tear things down and to bring them back up, and some debug features surrounding that. So that's something we're looking at, and we need to figure out how to do. On the power performance side, we have the cluster idle support. We believe it's almost complete for the modern platforms, but we need to integrate and test it out on the newer platforms. In particular, RB3 and RB5 would be interesting to see this on. We have work to do on the suspend resume path. I think we have this properly working on 7C, but there's more work needed on, in particular, on the other platforms, and in particular to make it actually so it seems like we can do suspend and resume, but it's not reducing any or significantly reducing power as it is now. So more work is needed there. As I said earlier, on the 7C, there was quite a lot of integration of interconnect with the various consumers. This needs to be done on other platforms, and there's more work there. There's the BWMON, which is a profiling based it's a hardware block or hardware feature we can use for profile based bandwidth scaling. So there's some ongoing work there, but that needs to be finished up and landed upstream to meet some of the power feature or power levels that we could do in idle, for example. There's the DTPM framework, which would resolve some of the downstream. Some could replace some of the features being implemented out of tree downstream. So there's more work going on there. And I think in my slides last time I said we were looking at QMI cooling, so that's still there. It's a cooling device where we can tell the remote proc firmware or the firmware running on the various remote procs that we want them to do things to save power and reduce their thermal footprint. On 8250, there is work ongoing to add Displayport support. We have most of that again on the 7C. The big difference towards RB5 and RB3 is the Type C handling. So there's work ongoing there. We still don't support the LEDs. I still need to repost the patches for that. I've done so twice, maybe since we met last time, but I got some more feedback to resolve there. And then we have the PCI power sequence needed for getting Wi-Fi up here, and that I think that ties into the ESOC discussion as well. And as Dev mentioned in his keynote, there's a bunch of mezzanine revolving around the RB5 platform. It would be nice to support some of those. And in particular, the communication mezzanine is it should be interesting, or it will be interesting to see how that can reuse what's done in the communication area with MHI and that. On the laptop side, so that's the 8180X platform. So I realized when I was preparing the slides that I ran into a merge window and never posted the device tree patches for that. So I still need to post those and hopefully land them. Sean has done quite a bit of work on supporting on getting enough ACPI support to be able to run the Debian installer on the HCX laptops. So there's still a few out of tree patches that we need to figure out how to handle. But the big item on this platform is to figure out how EDP and so embedded DisplayPort and DisplayPort works. We have the clock drivers. I think we have DPU support. We have the beginning of Adreno support, but we're lacking the embedded DisplayPort PHY, and we don't have the Type-C handling figured out for the DisplayPort, the external displays. On the 845 laptop, the Yoga C630, I have some patches for getting us backlight, but the backlight is driven by the display bridge, and when the display bridge waits for the panel to show up, the panel will never show up because it waits for the display bridge to provide the PWM chip that we're going to drive the backlight with. So I got some good feedback and good suggestions on that when I posted on RFC earlier on that. So I just need to figure out how to model those suggestions into the driver. Since pretty much the beginning, we have had pretty much a hack that gives us the battery status on the Yoga C630, because in Windows the battery driver is completely implemented in the DSDT, the ACPI code, and when we run with DT, we actually need a driver for this. So I should probably finish up or clean up what I have and get that, try to get that upstream. When you close the lid on the laptop, it seems to be suspending, or well, it does some of the suspend actions, but it doesn't seem to reduce the power consumption. Depending on how you measure, it seems maybe it actually draws a little bit more power while it's suspended than when it's just idling. So we need to figure out what's going on there. And then on the 8CX, the PCI PHYs are a little bit more dynamic in that it's up to the board vendor to decide which or what kind of lanes should come out of the few different PCI PHYs. So we need to figure out how to configure the QMP PHY driver to support those various modes. But when we do that, there's on the Lenovo laptop, there's SDX55 modem sitting there. So hopefully, based on the connectivity work that was done already, we should be able to reach the internet with that. Other ongoing things. So I mentioned earlier the SDX55 modem support. There's recently an effort to upstream the 7280 platform. So there's a stream of patches coming for this. There's the work on the 8350 will continue. There's patches in flight for interconnect, T-Sense, crypto, random number generator. At least I think there's more than that, but that's what I've seen so far. The SDX55 being a modem platform, typically found in a PCI endpoint configuration. So it would be quite interesting to see if we can get the PCI driver which so far has been RC only to play endpoint as well, and that will bring with it quite a bit of work in MHI and to get the endpoint side of things in place. There's work, far gone work on supporting the video encoder decoder on 8250. There is the CPU FREC support for 660 that is waiting for someone to give it a proper review. and there's the SMU. It's a little bit uncertain if it's a regression or if it did work previously or not. But at least we need something to deal with the SMU situation. On the 8350, charging and Type-C handling has moved to firmware that's running on one of the coprocessor. So we're looking into how to upstream the power supply and also the Type-C integration for that. And then one other thing that's ongoing is that we're apparently number one in warnings when it comes to make DTBS check, with thousands and thousands of warnings. So Vinod has started doing some good work there, but there is a lot of work left there to update bindings to YAML to make sure that the DTS file matches or follows the bindings and so on. So if you want to join us, try upstream on one of your boards. Subscribe to the mailing list, which the Linux ARM MSM mailing list is set up so that it gathers most of the Qualcomm related patches. Help improve the upstream drivers, upstream U drivers. We've seen quite a bit of community effort in upstreaming things that's needed for phones, for example, and that's really nice to see. Obviously, it would be really nice if you would like to review patches on the main list. We always appreciate that. And we have two IRC channels that are relevant for this. There's the hash Linux MSM, and there's the hash AArch64 laptops, both on Freenode. Yes, that's two hashes. And thank you for listening in, and thanks to the demo gods for taking us this far on as I run this on an actual Snapdragon laptop. So let's see what kind of questions.
You've had a good team actively answering questions in chat as you've been talking.
Oh, perfect. Thanks. So Linus is asking if the kernel features are implemented in a user space agnostic way. I think in most cases what we implement in the kernel requires whatever user space was there to be rewritten, but I don't think there's anything preventing it to be used in both cases, or from both say an Android or a Linux point of view. We definitely want to support a general Linux system. So yeah. This is over for you. And a question from Eric about missing frequency bandwidth scaling handling for hitting the highest loads or hitting the highest performance. I do believe that we're still lacking a bunch of work there, or there's some integration work to just get the existing OPP-based mechanism to hit the levels. Some of that I think is done on the 7C, but definitely not on these platforms. So there's more work there. 820 is things works, but they're not tuned. All of these, or all the three boards asked about needs additional work there. And then, then Linus asks about how do we deal with sensors? So sensors are typically dealt with by or implemented by the sensor hub, which is some form of coprocessor, and QMI or NQ router is used to relay messages back and forth between the Android lib sensor or the Android sensor hall and that coprocessor. There is currently no alternative to that. Last time I looked at the definition for the QMI messages, I fear that it would be too much stuff to put in the IAO or to make IAO drivers out of that. So that is an open question of how do we actually reach many of these sensors, because a lot of the sensors, or the general set of sensors, are all hooked up to this coprocessor. And Linus also asked about Ophono. I actually don't know what the status is there. And then Trilog says most of the IO-based sensors should be third-party components. Yes, so it's in many cases it's hardware components that we already have support for in IIO, or things that would be fairly straightforward to add support for, but they sit on this external coprocessor, and the means of getting there is rather convoluted and undocumented, or not publicly documented. Do we have any more questions, or are we good there? Thanks everyone for listening in, and feel free to reach out if you have any more questions or things to discuss.